Hi, this is Jeannie Martin, and I'm here to present my paper on modern day recycling for environmental science at Brown Mackie College. First of all, talk about what we use. Of all of our waste, 11.7% is combusted for energy, 34.5% is currently being recycled, and 53.8% is being discarded into landfills. And what is actually being recycled is glass and plastics, paper, metals, big run on electronics now with modern technology. Also biodegradable items such as food scraps and garden waste. With the invention of the disposable razor in 1885 and paper towels in 1907, paper drinking cups in 1908. Prior to all of that, there was a health officer who had said some time ago that we were going to need appropriate places for disposing of refuse, and those places are becoming scarcer by the year, and that the question as to some other method of disposal must soon confront us. And he had said all this before these three things were even invented. It all started, we've been recycling since early civilization. Obviously it's been more evident since World War II, when we were recycling a lot of metals and textiles for wartime. Also back then, charities were pretty much the ones that were taking in the household items to try and earn revenue, and they were collecting newspapers and aluminum cans and stuff. Some of the basics of recycling. Disposing trash and landfill maintenance costs approximately $22 a ton. Recycled materials that are resold have the capability to generate approximately $10 a ton. Some of the additional benefits are reducing the amount of waste we send to the landfills, conserving our natural resources such as timber and water and minerals. It helps prevent pollution by reducing the need to collect new raw materials. Of course, it saves energy. It also reduces greenhouse gas emissions that contribute to the global climate change. It sustains the environment for future generations. And there's jobs involved. It helps create new paying jobs in the recycling and manufacturing industries. Basic steps to recycling. Step 1 is collection and processing, obviously. 2 is going to be manufacturing, converting those back into a reusable product. And step 3 would be purchasing new products that are actually made from recycled materials. Residential recycling. Each American generates 1,600 pounds of waste annually. The equivalent of 29 pounds a week and 4.4 pounds of garbage each day. Collection methods, curbside method is costly. It's about $3 per household per month. Most homes are now supplied with recycling bins or big dumpsters, and more than 9,000 curbside programs exist now. There are also single stream recyclers who are the ones that will pick up a bin that's full of everything. We throw it all into one bin and then they sort it out when they get it. That makes it easier for more participation because people don't have to bother with separating it. And then they still get to sell it after they bundle it up after it's been separated. Education, a lot of education's been going on. Some towns are using VISTA volunteers to educate residents door to door. They're doing that in multiple languages so that people understand the importance. There are also some special programs being developed. A couple of those would be by Waste Management, like Lamp Tracker and Think Green from Home. There are drop-off centers. Those have reduced since the onset of curbside, but they're still out there and they're still important. They're good for large recyclables or people that are turning in recyclables for money, your aluminum, scrap, that sort. Some special drop-off items need special handling: car batteries, motor oil, carpeting, eyeglasses, automobiles, computers, fluorescent lighting. You see those advertised sometimes where they have special recycling drop-off days at Walmart or something. The resin coating system provides a common system for all the manufacturers and recyclers to identify product. There's a recycling code for plastic that was introduced in 1988. It helps to identify the resin content of the bottles and containers, and they're printed with numbers 1 through 7 depending on the type of resin that's been used. In plastics, type 1 is going to be the PET or polyethylene terephthalate. That's the soft drink and water bottles that we know and love today. Type 2, HDPE or high density polyethylene. Those are the hard plastics used in milk jugs, laundry detergent bottles. Type 3 is PVC or V, which is vinyl. That's your shampoo bottles, shower curtains, hula hoops, and credit cards. Type 4 is LDPE, which is low density polyethylene. That's the shopping bags, squeeze bottles, and carpeting type. Type 5 is PP or polypropylene. That's your syrup bottles, straws, Tupperware, and auto parts. Some are auto parts. Type 6 is PS or polystyrene. Those meat trays, egg cartons, CD cases. Type 7 is everything else. That also includes bulletproof materials, the 3 and 5 gallon water bottles like in your office water cooler, and sunglasses. We'll talk a little bit more about the Type 1 PET bottles. Those are the most popular, widely known. You see them everywhere. 1,260 million bottles are discarded every 3 weeks. Recycling of these reduces the mineral oil being used in manufacturing. There is some recycling legislation out there. Resource Conservation and Recovery Act of 1976. That set the guidelines for construction and operation and closure of the landfills. Since then, the number of landfills has dropped from over 8,000 to less than 3,000. So we're going in the right direction. The Electronic Waste Recycling Act of 2003, this is one that was introduced in California. It's regarding electronic waste items. It's a reduction in the hazardous substances that they can use in some of these electronic parts. Also, the collection of an electronic waste recycling fee when the item is sold. So you're paying for it right when you buy the item. Distribution of recovery and recycling payments to qualified entities. That covers the cost of e-waste and recycling. And a directive to recommend environmentally preferred purchasing criteria for state agency purchases. So they're going to make the government pay and buy the right stuff too. There's a Responsible Electronics Recycling Act. That is not currently enacted. It is proposed, and that will ban the export of certain type of unprocessed and non-working electronics and e-waste from the U.S. to developing countries. Coalition for American Electronics Recycling has shared some information. 3.6 billion pounds of e-waste is being sent to landfills or exported to other countries for recycling or reuse. If we keep the processing here, it could create approximately 21,000 full-time recycling jobs and 21,000 additional indirect jobs. So basically, right now we're just shipping it all off to somebody else to take care of. We don't want to deal with it here. Some recycling facts. Recycling 1 ton of paper saves 17 mature trees, 7,000 gallons of water, 3 cubic yards of landfill space, 2 barrels of oil, and 4,100 kilowatt hours of electricity, which is enough electricity to power the average American home for 5 months. That's just 1 ton of paper. Recycling paper, instead of making it from new material, generates 74% less air pollution and uses 50% less water. When you toss out 1 aluminum can, you can waste as much energy as if you filled the same can half full of gasoline and poured it on the ground. Americans throw away enough aluminum every month to rebuild our entire commercial air fleet. And 36 billion aluminum cans landfilled last year had a scrap value of more than $600 million. Every year we make enough plastic film to shrink wrap Texas. Americans throw away enough office and writing paper each year to build a wall 12 feet high stretching from New York City to LA. And contrary to popular belief, styrofoam is not recyclable. You cannot make it into new styrofoam. Zero waste, well, this is a concept. Every product and packaging would have a complete closed loop cycle, which means each component's either going to return to a natural ecosystem through biodegradation or be recycled indefinitely. That means no waste. It combines community responsibility with industrial responsibility to shift the emphasis to the front end. So before you even make it, you have to make sure that it's going to be recyclable or biodegradable. Right now, with all of the stuff we have, we're not that far advanced in our technology, so it's a little impractical. Some of the highly dispersed waste becomes so diluted that the energy that would be needed to recover it is real excessive. But it's something to work towards. Where are we going from here? Oh, additional education, continuing to educate the public in both residential and industrial. Improving our ability to recycle, make sure everybody's got the capability and the tools that they need, the recycling bins. Communities need to be involved. Everybody needs to take on this cause. 100% of the population needs to recognize the need for recycling. And of course, with the ability to recycle, we need to work towards 100% participation. We need everybody doing it. Thank you very much.